Good evening, everyone. Today's session is on scope and lifetime of a variable. So, we have discussed what are variables. Let's give a brief introduction. Let's be recap of what is a variable. So, when we talk about variables, a variable is a memory name, like a storage name, where you are going to save your data, right? Like suppose I am putting student name is equal to uh, Manvi, right? So I am holding this value. The Manvi is assigned to a variable that is student name. So student name that I have defined it as a variable, and that is of string, or you may say character type, right? So these are what? These are variables, or you may say if you want to store the age of a particular person, right? So I will be sharing it as, or I will be declaring it as age is equal to 20, right? So how the basically it is storing the age, right? It is storing the value that is 20 into a variable that is age. Now let us see what is the scope and how this variables are working within the functions, outside the function. What is the lifetime, what is the scope of those functions, right? So first of all, we have, if we want to reuse the same identifier, like I have defined x is equal to 20. I may be using within the function, within multiple functions. So I may use it, right, with the help of what? With the help of scope, hiding, and visibility, right? So the variable could be a local variable. The variable could be a global variable. Now, if we are defining it as a global or local variable, it defines the scope of the variable, right? Next thing is where this variable is defined, within the scope or outside the block. So that defines the scope. The scope of a variable is a part of a program or a block of program in which it is visible, right? If you are putting it in particular function, then its scope is local. If you are putting it in outside the function, the scope would be global. A variable is visible within its scope and invisible or hidden outside it, right? So basically, if a variable is defined within the function, and if you want to use it outside that particular function, you are not able to use that. The visibility of that particular variable is within that. The scope of that particular variable is within that particular function only, right? So I will be showing some examples on this also. Let us understand the first of all the terminologies that are behind this variables. Lifetime of a variable define the time for which the variable exists in a program. So how much time it is there in the program, it exists in a program, that defines the lifetime of a variable. Then what is the scope? Scope, I told you, scope determines the lifetime and the visibility of variable. So there are two things behind scope, that is lifetime and visibility of particular variable. Variables can be bound to a scope either statistically, or you may say statically. Sorry, not statistically. It is, I used to have statistical formulas in AI, right? So like statistical methods we have for calculation of correlation, or we are finding the positive. So uh, so leave that part. Either statically, or you may say dynamically. So it is, sometimes we call it as compile time or runtime also, right? So let us see how we define this thing. Static scope defines the scope of a variable in terms of lexical structure of a program. Using static scope, each reference to a variable is statically uh, bound to a particular variable declaration. Now, whenever we define it, at the same time we have, like the scope is defined at that time only. That is static variable. We cannot change it, right? We cannot have the different values for that. Yes, so this is the real, you may say the real definition behind that. Variables can be bound at compile time without regards to calling of code. So you are basically storing that value at the static time only, or you may say compile time. All variable references can be resolved by looking at the program source code and is independent of execution, right? So whenever you define it in a particular source code, the variable is going to like lifetime or visibility of that is defined under this only. Static scope rules are used by most traditional imperative programming languages like we have C, Pascal, we have Algo or Ada. Now let us talk about dynamic scope, or you may say runtime execution. Dynamic scope defines the scope of a variable in terms of program execution. So it is not defined at the time of compile. It is not defined before that compile time, right? It is defined at, yeah, it is defined at the time of like when you are executing the program. Next we have is each program declaration extends its effect over all subsequent statement executions until a new declaration of for that identifier is encountered. So whenever we declare any variable, yes, it is going to affect on other statements also, right? Like until and unless we have not defined any new declaration. Basically, first we need to understand what is basically lifetime visibility scope, and then we are discussing about static and dynamic, and then I will be telling some examples. I will be showing some examples through which you can identify like this variable is you may say is a static variable or a dynamic variable, or what is the scope of that variable, right? Variable binding can be determined at the moment code is executed, right? At the moment you execute that code, you can get the variable binding also. Dynamic scope rules are easy to implement but have drawbacks. Dynamic scope is most often interpreted in language APL, Snowball, or Lisp. So there are a number of programming languages which are supporting the dynamic scope. Dynamic scope is based on the flow of execution. So the father block of a block is one which call all the block. Like we have our main function, not where the block in the file, right? Now let us see one example. Yeah. So here we have in the first line, let us see how it works. Now int x, so you have defined one variable that is x, and that the data type of the variable is integer. And then we have put one comment. When we define one comment in any language, or you may say we have used C language, double slash is used for defining the comment, right? Then we have assigned the value to a variable that is 1, and what is the variable name, that is x. Then again we have defined one more variable that is y. Now here we have called one where here we have defined one function that is a void phi, and within this we have called the function that is foo, and here we have changed the uh, value of x. Now it becomes 0, right? Now again we have defined one function that is foo. Now we have written the code of for this, that is int x, right? And within x we have defined again redefined the value of x. Now let me tell you one thing. These variables, this thing or here, right? Or wait a minute, or you may say, yeah, these variables have the scope, that is these can be used throughout the program because they are global variables, because they are global variables which can be called in any of the program, right? But in case like in this particular function, this function has changed the value of x, that is 0, 1 to 0, and the scope of this variable is within this quotes only, this braces only, right? Beyond that, x is equal to 0, because is not possible because the scope of that variable, that is x is equal to 0, is within this particular code. Otherwise, what is the value of x? That is 1 that we have defined outside the function. Let us take another function. We have defined one function, that is foo. Again, we have defined a variable x, and now in this particular function we have changed the value of x to 5. Again, the scope of this variable is within this scope. Beyond that, x is equal to 5 cannot be taken, right? Now, you are reading the value of x, and then if x is greater than 0, then output is, then print some output, and if else you have some, you are calling the function, that is 5. So if y is greater than 0, right? Now if y is greater than 0, then what you are taking? You are taking int x. Again, you have defined one function, that is x, and you are putting some value into x, that is 4, and you are calling the function, that is 5, and within 5 you have defined x equal to 0, right? And then this is basically works like this. Your condition, how if statement works, your condition, and if your condition is true, then this part will be executed, whatever is written on this part. And if your condition is false, then this part is executed. Okay, so basically this is the condition. Now the condition is written here, that is y is greater than 0. Now if it is true, then this part will be executed. So this is the scope of the number of statements and that are coming after this. This is the true part, and else part is for false. So there is no braces, there is no parenthesis in this. So only single statement will be executed after this. After completion of if else statements, we have the next statement, that is write x. It is not under if part, it is not under else part. It is coming basically after your conditional statement. It is not lying within a true part or false part, right? It is coming after that part, right? So our output is like, when y is greater than 0, output is 1, right? Otherwise, when y is less than 0, the output is 0. How it has defined? By calling the phi function. We have seen this part. Phi, you have called the phi function. Now let us see, if x is greater than 0, y is greater than 0, then what is the value of x? When we come into the phi part, now phi function will be called, and phi is calling the foo function. Now we are moving into the foo function, and foo function has the value, that is x is equal to 5, right? Now x scope is within this, and above x, like foo function, in the phi also we have the x value that we have changed to 0, right? Now basically what we are doing is, if we have localization and if we have the scope of that particular variable, basically what we are doing is, we are checking the values according to that only. Where we have taken the value which is inside the function, this is the main concept behind that, and which function, which value is used, that is defined as outside the function. So here one value is, the output is 1. That means which value is used? That is x equal to 1. And if the condition is this, x equal to 0. So where this is in the phi function, right? So based on the true and this x equal to 5 or x equal to 4, it doesn't matter, because the scope of that particular value, the scope of that particular variable is within that scope only, right? Within that function only. Beyond that, it does not have any definition, right? Because we have defined the x variable as a local variable. I will be giving small programs on this, how it actually works, what is the flow of the diagram, right? Because if you take too many functions, first you need to understand what are the functions. Now, before you understand what are the functions, then you can easily identify how this flow actually works, right? Then let us see what is a lifetime. The lifetime of a variable is the interval of time in which storage is bound to the variable. What is the lifetime? मतलब how much time it exists in the program, right? The action that acquires storage for a variable is called allocation. Now, when you put some value into the variable and it is basically allocated, it specifies some memory, like if you are taking integer, some bytes are stored. If it is taking character, how many bytes are stored. So it acquires that type of, according to the type of data, it acquires the storage in the memory, right? This process of like defining the variable and assigning some value, and it is saved in the memory, so it is called allocation process. When you allocate a block of memory in a block in the memory, or you may saving the variable. Some languages allocate storage before runtime. This is called static allocation. I told you before runtime means compile time, when you are compiling your program, or you may say static allocation. So static allocation is what? When you are just compiling your program. So that is called static allocation. You are not executing the program. Others allocate storage at runtime, either using explicit request like malloc. You may have malloc functions, you may have calloc function, you may have reallocation also, new or automatically upon entering a variable's scope. I told you how we are talking about the scope. Let me tell you this thing. Let me change the color of the pen, then you can easily identify. Now, if we are defining these variables like x and y, and if we are defining, if we are changing or defining these variables, right? So how we use it? Basically, we have how we use it. We basically do one thing. Like if we are defining it outside the function, I am actually erasing the this thing, the yellow pen. Let me erase it also to make you clear. Yeah. So now let me write this thing. So yes. So these variables have the scope that is global variables. These are defined as global variables. Why? Because they are not defined in any within function, any function. They are not defined within a function. Right? They are defined, these variables are defined outside the function. Their scope is throughout the program. You may access it within this function also, or the variables which are defined inside the functions are basically, they have the scope that is local to that particular function only. Like phi x equal to 0 is local to that particular function only. So this is how, when we are talking about the storage part, it defines when we have a variable scope also, where the variable is defined. It is defined outside the function, or it is defined inside the function. If it is defined inside the function, that means its scope is local. If it is defined outside any function, right, so it is global. Other allocations, like when we have at the runtime, we are allocating the memory, we may be using some of the functions, some of the keywords, that is malloc, calloc, new. So these keywords are used for storing the variables at runtime. Languages may use both functions. It is not any constraint, or it is not any mandatory issue like you need to define your variable at static as at compile time, or you need to specify your variables at runtime. According to the requirement of the program, the developer is going to choose which of the allocation method is used. Maybe static allocation is used, or maybe dynamic allocation you can choose. So it is according to the this thing requirement. There are three lifetime in C. So lifetime in C means you have static. Auto, by default we have auto. Like when we have automatic variables, a is equal to 5, 4, a is equal to 10. So it is automatically defined. So by default it is automatic. Static के लिए we use static keyword. Dynamic के लिए we are outside, we are defining outside any program. Now let us see this program also. We have one function, that is info, in which we have defined, yeah, that's what I told you. We use static keyword for defining a static variable, right? We have for defining the dynamic function, we may use this thing malloc, right? So let us see some of the examples. A static int equal to 0. Count has static lifetime. Int star, pointer means pointer, counter is equal to what is the type of that? That is integer only. Malloc is the function for allocation of memory, and counter has automatic lifetime. If we are just freeing that automatic, or you may say if we are using malloc, so that means we have dynamic allocation. Then we have counter has automatic or dynamic allocation, then free. When you basically store some variable, so and you want to release the space afterwards, like after using that part you want to release that part, right? You want to free that particular block of memory. So which type of function, or which function you are going to use? That is free function. And free to whom? To counter. Which variable means? So that is the counter variable, because we are not freeing the static variable, that is count. We are basically using the free function for counter variable, for which we have used the malloc function for allocating the memory. So let us see the important points out of it. The variable count has a static lifetime, that is its lifetime is that of the program. The variable counter has an automatic lifetime. Its lifetime is till the function ends, because automatic means whenever if your function is over, or you may say by default we have automatic variables only. It points to a heap allocated memory block. I will be telling you how basically memory is segregated into different blocks. Right, its lifetime remains till it is explicitly deleted by the program. So now you have used some function for allocating the space in the memory, right? So it should be like free after the usage of that particular variable. So its life remains till it is explicitly deleted. So you need to delete it, or you need to free that particular variable after using, or after using that particular block by the program, which is not predictable, and hence it has a dynamic lifetime, right? So malloc, I told you malloc memory has dynamic lifetime. This is how basically we have the different allocations in a C programming. Now let us see, I told you what are identifiers that we use. I told you about local and global variables. A global variable scope includes all the statements in a program. The scope of local variable includes only the statements inside the function in which it is declared. The same identifier can be reused inside different functions to name different variables. Name is local if it is declared in the current scope, and it is global if it is declared outside the scope. So basically, if it is defined within the function, its scope is local, and if it is defined outside the function, its scope is global. A global identifier can be redeclared inside of. I told you this. Like suppose we have taken one example, x is equal to 1, and again we have defined in foo and phi functions. Again we have redefined the values of x. So it can be possible. Their scope is within that particular function only. Right? The new inner declaration is said to hide the old and outer declaration. Right? If you want to like use the inner part of that, so you may redefine it, and then or you may say if you want to reuse that particular variable. Some languages provide the scope resolution mechanism for referencing hidden variables. Let us see the examples so it would be more clear. Yeah. So int I. Now it is defined outside any function. This I is defined not within function. It is defined outside the function. So it is global variable, global identifier. Now this is the function, right? And again we have defined one variable. Within foo we have defined one scope where this parenthesis start, the outer part again one parenthesis start. So you have number of blocks within statements. So we can have as many as number of uh, blocks in our program, right? So in this function the first block is this one, right, where we have defined the I again, and then again this is the second block of function where we again reuse this I, and then we close it, and here we don't have. So again this is the outer part of 1 and this is the outer part for 2. So this is the outer part for second block and this is the outer block for first one, right? So the scope of variables, we can reuse the variables, right? We can reuse the variables by having the different blocks in our program, right? So its scope becomes local to that particular block. Then we have outer block, its scope becomes to that outer block. Then we have outside our function, that means its scope is the outermost variable is accessible by, can be accessed by any of the function, right? Because this I is a global variable, whereas within this particular scope, within this particular block or within this particular function, right, here we have defined its scope as local to that particular block, right? Its scope is not global. Another block is not able to access the value of I is, suppose I am putting I is equal to 10. So it would remain for this particular block only. You cannot have I equal to 10 in the inner block. Whereas when we have defined, you can reuse that I value. I have defined it like in the first statement, that is a global variable. I may reuse it within the number of functions according to the usage, according to the you may say the scope of the variable, right? So this is how we have different scopes, or you may say the visibility also. The visibility like the I equal to 10 is not visible to the outside part, right? Whereas this I can be visible, can be accessible in any of the, in any part of the program, right? So this is how we basically use these variables. The outermost I variable is accessible or visible everywhere. So this is the first part, that is called global variable. I will be giving a number of assignments on this, like How to, now you need to tell me about, like, these are the number of variables which are defined outside the block and their values are like this. So what we do in C programming, we assign different values within different blocks, so that our student and we must understand how the program flow and how a variable changes its value based on the different conditions. You may be using if else statement, you may be calling different functions, right? Based on that, the scopes could be changed, right? So hope you have understood the session, right? And understood the what is a scope varies among languages, and how, because I told you, scope allows to be nested. Every block or statement can contain declarations. Some allows declaration anywhere within the block, some only prior to any executable statement. So you may have nested blocks also, right? So it is, yes, it basically makes the program more complicated, but you may use the like special rules for that, right? So I hope you like this session, and we will be meeting in next session then. Thank you.